We'll continue from the client source part of push notification. Going back to the app, we can see the main class implements push callback. This is sometimes confusing to developers, so let me be completely clear. The push callback interface must be implemented in the main class. The main class is the one with the init object and start methods. It must be in that class with no exception, as it represents the object lifecycle, which is the underlying OS concept push binds to. We need one call to enable push, and that is the register push method. Notice that this call was changed recently, and both arguments were removed since both are no longer needed in recent versions of the API. Register push should be invoked every time the app runs. Let's scroll down to the most important method from that interface, the push string method, which is invoked when we receive a push. This method won't be invoked whenever push is sent from a server, as devices don't work that way. If the app is in the background and the user didn't click the push message, this method won't be invoked. Push invokes on build result method. This is important as the result call is also invoked from the polling fallback when push isn't available, so having common code is valuable here. The first call is of interest and might require some explaining of the various types of push messages. So let's skip for a second into a slide to review these types. I'll only talk about the three most important push types, but there are quite a few other types, and I recommend checking the developer guide when in doubt. First and most common push type is push type 0 or 1. This is the push type you see visually when an app that isn't running posts a notice like, "We haven't seen you in a while," or "You have a new message." This message will be seen visually on the device, and if the user taps it, you will get a call to push string. You will also get a call in push string when the app is running and a push is received. This is true for all of these push types. So the difference in behavior is when an app isn't running. Invisible push won't work when an app isn't running on iOS, but will work on Android. This is a conceptual issue. For iOS, push is a visual concept, whereas for Android, it's a communication protocol. In that sense, we recommend people don't use push as a networking protocol. It isn't very good as a networking protocol and is mostly used for signaling. Type 3 is here to work around the issues of type 2 and type 1. With type 1, we might not have the data we need to understand the content of push. So for our specific case, we might say app build completed visually, but we would expect to tap to trigger a download. And for that, we would need a URL. Type 2 is problematic, as we do want to show something to the user in this case. Type 3 includes two strings separated by a semicolon, one for the visual message and one for the data payload. The push method will be invoked with both of these in sequence, one after the other. Let's go back to the code again. As I said before, this if statement is interesting. The reason we have it is simple. We sent a type 3 push that includes both a download completed message and a URL to launch. If the push message isn't for the download URL, then it's just a visual message and I don't care about it. I relied on the fact that this is a URL, but it would have worked even for a JSON string, for example, checking that the string starts with a curly bracket. The rest of the code isn't really related to push. It just shows a dialog to download the finished app if necessary, but it's not about push, so I'll skip it. It's relatively simple code anyway. These are the two other callbacks for push. Registered for push is normally very important. The push key value will only be available after this method is invoked. Normally, in this method, we send the push key value to a server so we can send push messages to this device. However, in this case, we only use push when a build is sent, and by then registration either completed or failed, so we can check the push there. A common pitfall with this method is usage of the device ID argument. This isn't the push key, but rather the OS native ID. To get the right push key, you need to invoke push.getPushKey. The second method is invoked when there is a registration error. Notice that this isn't always invoked, and sometimes it isn't called for a device where push is unavailable. Another important thing to highlight is that this is a very bad implementation. When I did this, I didn't reproduce the error, but this could trigger an error at a relatively early point in launch and produce a very problematic toast message. Normally, this should be handled later on or logged.